Hello again. This is Brian recording a briefing video for Project Zero, the first project you'll encounter in CSC 143. You can check out the Project Zero webpage when you visit the class syllabus, scroll down to the schedule, and then click on the to-do that says Project Zero. Project Zero is going to kick us off with a discussion about test-driven development. I've already taught you about software testing and how we write unit tests and integration tests using JUnit to evaluate the correctness of our program as well as enforce its specification. For all the projects in this class, we're going to be using test-driven development to specify how our program should behave first in advance of actually implementing the programs themselves. And the convenient thing for you is that I've already gone ahead and written all those tests for you. So what you're going to be getting when you download the project code, which you can grab from this link here, is a shell for your program with a bunch of unfilled class definitions and several test cases that you can run to validate your program implementation. I've already gone ahead and downloaded my Project Zero starter code. If you have not, just go ahead and click here and it should give you a zip file. Unzip it into a location convenient to you, and then open it up inside IntelliJ. Okay, here's my Project Zero. I've opened it up inside IntelliJ. You can validate that your program has loaded correctly by right-clicking on the Project Zero evaluation file and then clicking on Run Project Zero Evaluation. If you don't have that Run option available, make sure that your project is configured correctly. To do that, go up to the File menu, click on Project Structure, go up to the Project tab, make sure that Project SDK is set to 11, make sure that your project language level is set to SDK default, which is also 11, and make sure that there's a folder for output available specified here. If not, go ahead and create one and then specify that path. Next up, make sure that sources folder is correctly identified as a sources folder, and make sure that the lib folder inside source is correctly identified as a library. If not, go ahead and add it now. Okay, that should be enough to get our project running. You can actually run any of these files by right-clicking on them and hitting run, and you'll start to see how we can interact with the test suite inside IntelliJ. For example, one of the classes you'll be implementing is hello. I evaluate it on a number of things, and if I try to run the hello test right away, I'm told that all those tests fail. So the sweet thing about IntelliJ is that it recognizes that this is a suite of JUnit tests because it supports JUnit out of the box. It recognizes that I have all these @test methods, these @test decorators across all these methods to indicate that they are tests, and I can right-click on the file name, or I can click on the arrow next to the name of the class to run all the tests inside the program. Now, this is slightly different from a main method. In the other examples we've seen so far, we have that main method, which is the entry point for our file. When you start to run this Project Zero evaluation, you'll see that main method as well. Now, every Java program does have a main method, so it's not like it doesn't exist. But what IntelliJ is doing is it's calling upon a main method inside JUnit's test runner, and is essentially passing along this class to JUnit so it knows what to do. So even though there's not necessarily a main method here, IntelliJ is smart enough to know how to run these tests and produce output for them. Okay, now let's go back to the project specification. Let's start out with some simple practice. I've got a package called hello and a class called hello. I ask you that it says hello world. With a little bit of a twist, hello is going to implement the comparable interface. In the angle brackets here, I specify that hello can be compared to other instances of hello. We learned about comparable last class when I talked about how interfaces specified a list of methods that implementing classes were required to implement in order to fulfill those interfaces. You can read more about how comparable works here, but there's also a short summary down here, which I talked to you about how you need to fulfill that interface by implementing the compare_to method. Anyway, there's really only 4 methods that you have to implement other than compare_to. You'll need a constructor that just builds a hello object without a name attached, a constructor with overloading this name argument that accepts a single argument name, and constructs a hello object with that name stored inside, a method called greeting that returns a string, and it returns a greeting string that greets the name or the world if there is none. And a toString method also returns a string that does the same thing as greeting. Let's go back to the project to talk about how I'm going to enforce this specification via the test cases. If we go to hello, we see how there are essentially method stubs available to you, and I'm asking you to fill out these method bodies to meet the specification. Now, hello itself doesn't really do anything useful. I actually provide you a main method that you can run just to have some fun. If you build a hello and you call hello.greeting, you actually get the empty string out because greeting doesn't do anything other than produce the empty string. Same for this version of hello, where I construct it with a name there, and then I try to print out the name. It should just print out also the empty string. This is kind of a sandbox main method. You're welcome to edit it, but you really don't have to. And you can run it, of course, by pressing that green arrow. So this hello doesn't do anything useful for us, and it's not exactly clear what should be happening here. And when we go visit the hello test, we start to get more information about how hello should behave. So remember that tests are not magic. Hello test is just a Java class. This @test decorator tells IntelliJ and JUnit that this method is going to be a unit test or an integration test. Then you can go about defining these methods like greeting test world, greeting test name, and so forth. And we're going to use these assertions to verify and validate that the class is behaving as we want it to. So here in greeting test world, I see that I construct a new hello with no arguments, and then I assert that the output of hello.greeting should give me hello world. This is enough information to tell you, as the programmer, that the greeting method should return world, or hello world, when invoked upon a hello that takes no arguments when constructed. The slightly more advanced example, greeting test name, takes a single argument. I've called it there, and when I call greeting rather than printing out world, we saw that the expectation was that it gave me there, so I said hello there. We see that replicated here when I create a hello instance with the name earth, and then I call greeting and I get hello earth. So you can start to see how these test cases are going to enforce how we expect the hello class to behave. Here I've got some examples where I try to use that toString method, which is going to behave the same way as we would with that greeting method. The reason I have you explicitly overriding toString is because toString is actually a very special method in the world of Java. In Java, most classes don't really have very much going with them if you just define the class with an empty shell. toString happens to be one of those methods that's inherited from the top-level global object class. You can read more about the object class online on Oracle Java docs, but what you need to know here is that toString is actually an inherited method. It just so happens that the toString that it's inheriting doesn't really do anything useful for us. We might explore this in a later lecture, but what you need to know now is that toString is actually a special method in Java that Java can intelligently call at times when it needs to convert a class to a string. So by nature of everything having a toString, because everything inherits from the top-level object, everything can be converted to a string. Now, whether or not the string that's produced by toString is useful is up to the programmer. So here is going to be your chance to define a meaningful implementation of toString so that the hello class can be converted to a string. Okay, lastly, let's talk about this comparable interface again. And we'll start out by going back to the class notes actually. I tell you about this compare to method. Remember that interfaces are going to obligate implementing classes to implement the methods defined in those interfaces. They just don't say anything about how those interfaces actually have to be implemented. So down here inside my compare to method, I tell you that I return an integer that indicates how this, which is a reference to the current class, and other, which is a reference to the argument, should be arranged in natural order, such as ascending order. For this particular implementation, I'm asking you to order these hello instances by the length of the greeting. So hello instances with longer greetings will come after instances with shorter ones. The logic is as follows. If this, which is the current reference, should be ordered after other, return a positive integer. Otherwise, if this should be ordered before other and has a shorter length greeting, return a negative integer. Otherwise, if the two instances are equal in ordering, return 0. You can check out the test cases for a concrete example of how the compare to is used. Let's take a look. Here I've got my hello comparable. I can define a hello that is assigned to a comparable of hello type because I know the hello class implements comparable of hello. I can even verify it in code here using this assert true statement. Meow. Sorry, my cat's wanting some attention. Hello, Peaches. I've got 3 hello instances defined with Alice, Bob, and Chris. As we can expect, Alice and Chris are probably going to be equal because they have the same length greeting, but Bob's going to come first because he's got the shortest name. So when I do hello A to compare to hello B, I would expect that Alice comes after Bob, and I get a positive integer when I call compare to. Respectively, when I call hello B compared to hello A, Bob should come in advance of Alice because Bob has a shorter name, and I should be returning a negative integer. Here's a pretty neat example. I've created several versions of hello, Alice, Bob, Charlie, Dominic, and Ed, and I'm going to go ahead and use the native Java collections.sort method to arrange these hello instances in a sorted order. The neat thing about the comparable interface is that it's one of those built-in Java library interfaces that has certain meaning in terms of other Java library classes. By nature of things being comparable, allowing us to compare them to other things, the native Java collections.sort is going to know how to actually arrange these instances without any additional intervention. Well, what do I mean by that? You would expect collections.sort to understand maybe how to sort numbers, and maybe by extension, how to sort strings. But here we've defined our own class. This is a custom class. We, as the programmers, have to decide how we want to arrange each of the instances of hello. In this case, it's a pretty simple implementation. I've only arranged it by the length of the name or the length of the greeting. But you have to tell collections.sort to identify the axis in which these individual instances need to be sorted. Because we've gone ahead and implemented compare to, collections.sort can invoke compare to on these instances and identify how they should be ordered in a natural way. So when I start out with hellos A, B, C, D, and E, and I sort them using collections.sort, I get E, B, A, C, D on the way out. As usual, you can run all these tests by clicking on the little icon. You can debug them as well, and you can run them individually if you click on the icon next to the test definitions. Okay, I think that's pretty simple stuff. Now let's move on to something a little more interesting. Hello.range. Range is a class inside the hello package. And what I'd like you to do is implement Python's range in Java. Range is a function that provides a sequence of numbers in Python, and it's going to implement the iterable interface, which requires that range fulfills the iterator method, which is something we explored in last class. The iterable interface is going to describe objects that can be iterated over. Things like arrays, lists, maps, trees, and many other data structures we will learn in this class are going to be iterable types. Let me pop out a Python shell and talk to you a little bit more about how range behaves. Go ahead and make my font size bigger so you can see. All right, let's drop into Python. In Python, you might not see the exact same for loop syntax as you would in Java, the C style for loop. Instead, you'll see something like for x in range 5, print x. And that gives me the numbers from 0 to the argument exclusive. So I get 0, 1, 2, 3, 4 on the way out. And what's actually happening here is Python is using this for each or for in loop construct to identify the individual elements that exist inside the sequence on the right-hand side. Then when I say for x in range, x automatically gets assigned to the value that it pulls out of the sequence. And that sequence is going to go up in each step of the loop. There's actually 3 ways you can define range with 3 different types of arguments. If you do it with one argument, it's actually just the end. This is actually a typo. This should say stop. So if I say range of 5, it should give me 0 to 4. The 2 argument version gives you a start and a stop, and the 3-argument version gives you a start, stop, and a step. So let's say we go to for int x in range 2, 5, and 3, print of x, and it gives me 2. It doesn't give me 5 though, because 5 is beyond the last number in the range. So be very careful about how you actually go about maintaining the internal state of this range object, because it needs to be smart about what the last number is going to be. So I'd like you to implement this range, and I'd like you to make it an iterable type. So what is an iterable? We explored the iterable interface last class, and we talked about how iterable is a Java library interface that describes classes that can be iterated over. We talked about how a simple C-style for loop can be used to create array indices for arrays, and we can use that for arrays, but not everything necessarily has indices, right? If you have a map object or a tree object or a linked list object, these are all structures that we'll explore in the future. It doesn't necessarily make sense for indexing to be possible on those objects, but it does make sense to be able to iterate over those objects. So an iterable just tells Java that this is going to be something I can iterate over. Iterables are obligated to supply iterators. Now what's going to happen is you're going to have to define a method called iterator that returns an iterator. Iterator itself is an interface, and we're going to fulfill it using a range iterator class. So an iterable is something we can iterate over. An iterator is like an individual who is performing iteration. An iterator, which supplies the integer sequence of a range, is going to go about retrieving the individual numbers within a particular range and outputting them until the iterator itself is exhausted. Iterator is going to supply a couple of things. It itself is going to have a constructor that matches the signature of the range constructor with 3 arguments. Then it's going to implement 3 methods. The first one is hasNext, which is akin to asking the iterator whether or not there's values remaining. The next method is next, which is going to retrieve the next value in the sequence from the iterator and then push the iterator forwards. Then there's this remove method, which we'll just throw an unsupported operation exception with. It's pretty easy to get iterables and iterators confused. So the example I like to come up with is we can have an iterable that's something like a tree in real life, and an iterator is somebody you hire to count the individual leaves inside the tree. You can have as many iterators as you like for the same iterable, but each iterator is going to have its own state. You might have somebody who's on the 500th leaf, you might have somebody on the 0th leaf, and every time you call next on them, they're going to go tell you about the current leaf they're on and then move on to the next one. So the iterator is kind of like an observer of the iterable. The iterators themselves are independent and they spawn out of the iterable as a means to walk the underlying structure. Now here's a big hint, and I'd like you to follow this hint. When you implement range, you do not need an array, array list, or any other storage container to actually store the underlying values. Instead, what I'd like you to do is something called lazy loading. I'd like you to compute the output of every call to next on the fly. What do I mean by that? Well, if I call range of 5, I know the values are 0 to 4. I know the value starts at 1. I know the values start at 0, and I know they end at 4. All I really need to know, therefore, to go on to the next values when I call next, is where I started, or where I'm currently at, what my step size is, which is 1, and what the limit is, which is 4. So if I start at 0, all I have to do is add 1 to get the next value. Then if I call next again, I add 1 to get 2, the next value, and so forth until I reach 4, which is of course the last value, and then calling next one more time is not going to let me do that because I can't retrieve 5, and hasNext should return false. Let's talk about how that looks inside the project code. Here's my range definition. I've got those three constructors that are each overloading a particular property of the range. And then I have the iterator method, which is going to return an iterator type. That iterator type is going to be fulfilled by this range iterator concrete class, which implements exactly that type. The range iterator itself is going to have a 3-argument constructor, and then it's going to have these methods hasNext, next, and remove. Then let's go take a look at range test. I've got some pretty simple tests leading up to more complicated ones for your range. For example, I start with a range test of 0. I expect that a range that has just the value 0 does nothing. It has no next. I expect that, like in how I showed you in Python, range of 5 should give me the values 0, 1, 2, 3, and 4 on the way out. Then I tell you about a rather interesting loop construct. Remember that for in loop inside Python? The Java equivalent is for each with this colon operator. And what Java's going to do is when you write this kind of loop, it's going to call the iterator method on the object you're iterating over, and then it's going to perform the same thing as walking all the values of that iterator by calling next repeatedly in the body of the loop until the iterator itself is exhausted. So this for each loop in Java is actually shorthand for this big block of code, but we saved ourselves the hassle of having to actually write all this code out and creating this temporary variable. So down here, range of 0 should give me no values. I'm counting nothing. Then over here, range of 1 should just give me exactly 1. And down here, I got a range test of 5. I should have new range of 5, give me the values 0, 1, 2, 3, and 4 when I use the for each loop on that range construct. Another point I want to make here, range itself should be reusable. Remember that the range itself is the iterable. It is something I can iterate over. And the individual iterators are the people observing, the classes observing these individual range elements. So what I mean by that is this range itself is going to be static. It's going to have 5 values all the time. But I can pull out any number of iterators that I'd like to walk all those 5 values. Again, it's like hiring several different people to walk the same tree. They can each have their own independent state, and they don't interfere with the underlying structure, and they don't interfere with one another. So over here, even though I've exhausted the iteration at the end of this loop, I can still walk that range again and get the values on the way out. So there's nothing stopping me from just repeating the iteration. There's some more interesting examples down here. Here's an example where I try to call next after there are no elements inside the range, and I expect you to throw a no such element exception. What's kind of clever about this code block is that the exception is thrown in between lines 121 and 122. So it actually skips this fail call, which would ordinarily end the test, and go into this empty catch block so the test could keep on going. There's a couple of other fun examples in here that I'd like you to implement. I encourage you to explore and implement these one at a time. Start at the very top and slowly make your way onto the way to the bottom, and run these tests pretty much every time you change your code. Over time, you're going to slowly start to make progress on getting these tests passing. And if you ever have trouble, remember, set breakpoints and switch to debug mode so you can inspect the internal state of your running programs. Okay, so that's all you need to know for the project specification. Now let me talk to you about how you actually run this and evaluate it for the sake of grading. I've given you a file called Project Zero Evaluation that you can run independently, and it's going to spit out a grade for your project. As I told you in the syllabus, the grade for your project is not exact. It's a prediction. Every test in the project is worth the same amount. It essentially divides 100 by the amount of tests that are in the project. So here there's 17, so each test is worth 100 divided by 17. And the score that you get on the way out is just a function of how many tests that you're passing. So if you want 100, you of course need to pass all the tests. I also mentioned in the syllabus that the score you get from Project Zero Evaluation, or whatever evaluation script you're running, is not a guarantee of the score you get when I actually grade these projects. And that's because I expect you to implement these projects correctly. You can go about cheating the tests by printing out exactly what the test asks of you, but of course that's not right. That's not a real implementation. You don't get credit for those. So when you're walking through these tests and thinking about the specification that the tests define, think about how you actually go about implementing them, rather than how can I get the highest score as quickly as possible by cheating the tests. So it's really not worth your time. You're much better off just actually implementing it as it is. Now let's say you don't use IntelliJ. That's okay. You can use any IDE you want in class. I've also given you some run scripts that you can run directly on your terminal that is going to do the same thing as running Project Zero Evaluation. It's not quite as nice as running these tests directly because you don't get the UI of IntelliJ, but it's an option you can do. And in fact, it's what I'm going to do when I actually grade your projects. I've given you two scripts, run.bat and run.sh. If you're on Windows, I want you to run run.bat. And it's going to, whoops. I'm in the wrong folder. I need to cd into source. Make sure your working directory is up to source. And then you can run a script using / the script's name. And inside this run.bat script, all I do is I trash all the existing compiled files if they exist. I go ahead and compile it using Java-C, and I point to the lib directory as the library code, and then I run Project Zero evaluation. Let me tell you about how it's done if you're using Mac or Linux. BAT stands for batch, it's Windows only. SH stands for shell, it's for Mac and Linux. If you happen to be a Linux shell, you can use /run.sh. One little quirk, Windows uses backslashes, Mac and Linux use /. So I guess be careful of that typo, and it'll throw an error if there's a problem. This is the script that I'm going to be running when I grade your exams. Not your exams, your projects. So even though your project may succeed if you right-click on one of these individual test files, it's generally a good idea for you to also run these scripts directly. It's going to give you the reassurance that what I run on my computer is going to run the same on your computer. One more thing, some of these tests are pretty complicated. The deeper you go, the more complicated they get. You can change these tests up. If there are assertions you're failing but you're not sure why, you're welcome to block out certain parts of the test to simplify the test. That's going to be part of your debugging experience. On one hand, you can start setting breakpoints and walk through your code step by step. On the other hand, you can cut down on the size of the test and the complexity so you can get a better understanding of what's going on. That being said, when I actually run your programs on the test cases when grading, I'm going to override whatever's in your test folder with a native copy of the current test cases, an unmodified copy. So you can't just go about calling pass on all these test methods and getting 100 in the test script and assume that you'll get the same thing when I actually grade your program. I'm going to grade your program on an unmodified, fresh version of the test cases. At the same time, don't forget, if you modify these test cases, make sure to put them back to where they were so you get an accurate reflection of how they behave. When you're done, please fill out the README file. It helps me figure out who you are. Then I'd like you to zip up the top level folder, CSC 143 Project Zero, and submit it to Canvas. This project is going to be due about a week after I sign it at midnight in Pacific time. Please be sure to submit it on time. The late policy details are going to be on the syllabus, and I'm more than happy to answer any other project questions you might have and help you out with progress on this project on Piazza. Thank you for listening, and I'll talk to you next time.